Hi guys, today I am going to explaining about the formulas for inverters. So I am going to explain all formulas in half bridge inverter, full bridge inverter and three phase inverters. All the formulas like Fourier series and their RMS values and their average values. So I will explain each and every formula in this module. Okay, before going to start the tutorial, I would like to thank Mr. Sohali Ansari sir. He is the founder of Gatematic. So he is our inspiration. So without wasting time, let's begin our first tutorial on inverters. So I am dividing this into the three parts. One is the single phase half bridge inverter and single phase full bridge inverters, and another one is the three phase inverter. Okay, so for half bridge inverter the factor is 2, and for full bridge inverter the factor is 4. Okay, so as you know, for single phase inverters we have only odd harmonics, that is n is equal to 1 3 5, means you don't have the even harmonics. Why? Because it is the if you plot the waveform, you will get like this. You will get like this. That means this is the odd wave. That means it is the odd wave symmetry. That's why you will get only odd harmonics. You don't get the even harmonics. But for three phase inverter we have odd harmonics. That means we have n is equal to 1 3 5 7 like that. We have the odd harmonics, but in that triplet harmonics are absent. That means you don't have the triplet harmonics. That means this will be eliminated. 3 6 9 means multiple of the 3 harmonics. That means 3 into 1 is 3 and 3 into 2 is 6 and 3 into 3 is 9, means multiplication of triplet harmonics will be eliminated in three phase inverter. So these two things you have to keep in mind. That means for single phase you will get n is equal to 135, but three phase you will get only 6k plus or minus 1 harmonics. That is n is equal to 6k plus or minus 1 harmonics, where k is the 0 1 2 3. If you take the k is equal to 0, you will get plus or minus 1. That means first harmonic and the first harmonic. If you get the k is equal to 1, you will get fifth harmonic and seventh harmonic. So like that we have the harmonics in the three phase. Okay, so if you remember these factors, for half bridge inverter you have the 2 is a factor, for full bridge inverter you have the 4 is a factor. You can able to write the Fourier series expressions of any type of inverters. Now for writing the formulas for three phase inverter, so I have taken this diagram. So this is the short trick, means this is a tool to remember these all the formulas. Okay, so in exam you don't have the much time to derive all the Fourier series expressions in the examinations, so it is better to remember like this. Okay, this is for only remembering purpose. Okay, if you want the full explanation how you got this Fourier series expression, so go to the Gatematic YouTube channel. There Sohali sir explained each and every formula, means with explanation, with the derivations and all. So I am only explaining the how you remember these formulas. Okay, most of the students confused how to remember these formulas, this much of bulky formulas. Okay, so that's why I am making these videos. So in three phase inverter you have the two modes, that is a 180 degrees mode and 120 degrees mode. Okay, so this is for phase voltage and this is for line voltage. So for phase voltage the factor is 2, and for line voltage the factor is 4. So remember this, for phase voltage factor is 2 and 4, and for 120 degrees mode for phase voltage the factor is 2 and the phase line voltage the factor is 3. Here, so for line voltage you have the 30 degrees phase shift. 30 degrees means pi by 6, and for here 120 degrees mode for 3 phase 120 phase voltage you have the 30 degrees phase shift, that is a pi by 6. Here you have the 30 degrees phase shift in the line voltage, and here you have the 30 degrees phase shift in the 120 degrees mode phase voltage. Okay, this means these two are related, means these two are correlated, and these two are correlated. If you draw the waveform of these two, so these two are symmetric. these two are symmetrical about same, we will get the same waveforms. Okay, and these two are symmetrical waveforms. Now for 120 degrees mode, line voltage is the factor is 3. So the factor will be 3, and it has a 60 degrees phase shift, that is means pi by 3 degrees phase shift. So I will show the waveforms of all these when I taught these formulas. Okay, now so when it is a 30 degrees phase shift, you have to multiply with 60 degree sine of 60 degrees. Okay, remember this, when it is 30 degrees phase shift, you have to multiply sine of 60. That's why I written like this arrow mark. And when it is a 30 degrees phase shift, same, these two are same. When it is 30 degrees phase shift, you have to multiply sine of 60 degrees, means 6 degrees, you have to multiply in this formula. Okay, so this you keep in mind. And so remember these formulas for writing the Fourier series of 3-phase rectifiers. So, and we have the another formulas, that is RMS voltage formula. You know already, for the sinusoidal, what is the RMS value? That is equal to maximum value by root 2. And here G, so distortion factor, G is called distortion factor. For AC you have the distortion factor, and for DC you have the voltage ripple factor. This is a ripple factor. So distortion factor is fundamental, V01 means fundamental RMS voltage divided by V0 means output RMS voltage. So fundamental voltage is the output RMS voltage, and you know total harmonic distortion is root over 1 by G square minus 1. So remember these three formulas. Okay, so in the next video I will explain how to write the Fourier series for half bridge, full bridge, and 3-phase inverter by using this simple 2, 4 and here 2, 4, 2, 3 values. Okay, so for more updates, subscribe to my channel and comment in the below, means how you feeling of these formulas. Okay, so if you comment, I will make more videos by analyzing some more formulas. Okay, thanks for watching this video.